Welcome back, everyone. We're just doing a bit of work here to help you with the chapter on negative numbers, and we're up to the stage where we're doing a little bit of algebra here, another little step or an exercise focusing on substitution and just trying to help build your capacity to work algebraically. And I think it's always good practice, but we're doing it in the context of we might be inserting some negative numbers in there. All right, so in year 7 at the moment we're still learning algebra, and people have varying degrees of ability with this type of work and various experience doing this kind of work. So when we see a letter, we call that the pronumeral, and I've got some blank cards here, just some blank bits of paper. I've called this pronumeral A, and what we need to think about is that sometimes in algebra I don't know what the value of A is on the other side of a card. If there's a set of playing cards, one side might have a letter here and we need to know the value of it. Okay, we can work algebraically without ever knowing what's on the opposite side of this card. All right, but eventually, and what every question is going to say to you today is the value of this letter is worth something. Okay, and that might be -3. Okay, so on the opposite side of this card, A is worth -3. So we'll always start by writing out the algebra, and then we'll drop down underneath, because I really like setting things underneath, and we'll replace the A when we rewrite it with -3. Okay, you are most welcome to put that -3 in brackets if you like. I don't mind. All right, just as long as we swap out the letter for a number. And importantly, because we're doing negative numbers, I want you to take really a lot of care. Is that +3 or is that -3? And if it's +3, why don't we do this? Why don't we actually write down that it's a +3? Okay, because that will reduce our chances of making mistakes as we go along and crunch the numbers. Okay, so every letter in algebra, say if we choose the next letter in the alphabet, we've got a B here. What are we going to give this B a value of? I don't know, let's make it -5. Seem to like that number, but here we've been told we've got the letter B, and we've got the value of -5, and we're going to substitute that in instead of the letter. And then once we've done that step of substitution, we can go ahead and crunch the number. Okay, and we can employ all those steps that we've learned along the way about adding and subtracting, being careful of signs, multiplying and dividing, being careful and mindful of what's happening with the sign of the answer with each of these steps that we do. And of course, there's a few other questions I'll show you, some measurement style questions, and a question in there that's related to time that's probably worth talking about and mapping out on the lightboard to help you with your work. All right, thank you. What I've done here, I've just kept the information on the left-hand side here, because it still applies. Even though we're doing some algebra now, we're doing some substitution. So the nice thing here is that you'll always be told what the value of the pronumeral is. And I would insist that you write out the algebra first, and then you look and say, I've got an A there, I've got a pronumeral A there, what's it worth? And if it's worth 3, write out a statement like this. Okay, because every question will have a pronumeral, and it's just so easy to get mixed up. Even when you look write the algebra down and look back at the book, you might look at the wrong question and get the wrong value. So write this out as your first statement. And now we know what the value of A is, so we can do this. Underneath here, we can do the substitution step. And it's implicit multiplication there. It's 4 times A. So we're a bit lazy in maths. If we don't have to write a time sign, we won't. So we can do that. Okay. And then, of course, BODMAS kicks in again. We need to do the multiplication first. So we've got 2 plus 12 equals 14 as our final answer. There's no signs there. We're dealing with a positive value of 3. You could have done that as well, just to reassure yourself of the answer. Let's do it again. I'm going to change the pen, and this time I'm going to say, what am I going to do? Get rid of all that. And let's try it again. 2 minus 2 minus 4A. And this time we're going to make A equal to minus 6 and see what happens. Okay, so we've got our algebraic statement written down. We've got the value of A written down. And now we're into the substitution. So I like to line things up underneath each other, especially in this step, so I don't make any mistakes. So I'm going to put brackets around that and help me concentrate on what's happening inside of here. 4 times a negative 6, that's going to be a negative 24. Okay, now we're in this situation. We've got subtract and negative. So again, we're going to change those to plus positive is what I say, or back on over here when we look, we're adding the opposite. So our answer there will be, we started at minus 2, we added 24. So we're going to finish up at positive 22. If we're just thinking about that in sense of the number line. But if it helps, you can rearrange this. There's no real issue with you rearranging it like that either. And that helps you see the answer as well. Okay. And by the way, there's nothing stopping you drawing a number line here, putting minus 2 there, adding 24, and ending up at positive 22. Okay, so one more example, I think, and we will, I'll just clean the board and use this space again so we can see what to do. And this time I'm going to include 2 pronumerals. And what I'd like you to do is write x equals, what are we going to, minus 7, comma, y equals 2. And set it up like this. So let's do our substitution. 5. Make sure, because you've got to be really careful. That's why it's good, because your eye can look and double check that you get things in the right spot with your substitution, so you don't make too many mistakes. Again, here's this subtract and negative, and this is what we're going to do. 2 plus 7 is 9. All these numbers are nice positive numbers, and our final step here will be, just remember, this again is an implied multiplication. There is a multiply sign there, so we can do this, and that is positive 45. So there's two more things I want to show you really. One of those relates to some measurement questions that you've been given, and I know, let's just draw a rectangle here, and I'm just making this the length and this one the width. Okay, so there's questions relating to perimeter, and we can shorten the length to L and the width to W. So we've got two sides, two lengths, plus two widths. Now don't get confused, area is a different thing. We're multiplying the length by the width here. Now we're in the physical world here with our shapes. So the question for you is something along the lines of, let's make the width equal a negative number, okay? And let's make it equal to -8. And while we're here, let's make the length equal to +2. Now, mathematically, we can work out the perimeter, and that's 2 times the length, which is 2 times -8. I'm just going to set it up like that. Remember, that's a time sign. Plus 2 times +2. So this side is 4, and this side is -16. And the perimeter here, when we add all those things together, will be -12. Now, the idea is interpreting what that negative sign means. Okay, and area is length times width. So length times width, that'll be 2 times -8, and we end up at -16 units squared here. And again, what does that negative sign mean in the context of working out perimeter and area? And one of the questions asks you those things. And can you have, when you're in the physical world, could you have a negative dimension? And I'll just leave that as an open-ended question for you to ponder. The final thing we need to do or discuss or think about is another question here involving time. And just really quickly, might be worth doing this. There's a question there what I really like, and it's looking at speed of an object. And speed isn't measured in meters per second here. So we've got, let's put a 0 in there, and we're measuring this over time. And this object is moving at according to some formula, okay? And that formula could be 20 plus 3t. And t is for time in seconds. And here's a good bit of overlap for some of the physics that you might do later on. And you've been asked at different time points what is the speed of this object. And one of those, let's do an easy one, t equals 0. And we need to substitute that into our formula of 20 plus 3t. So that's 20 plus 3 times 0. And that goes to 0. And so we're moving at 20 meters per second at time 0. Now, we might have time equal to -2. And we need to redo the calculation. So 20 plus 3t, 20 plus 3 times -2, 20 minus 6 equals 14 meters per second at t equals -2. And then up here we might have time equals 4. And again, it's a process of just substituting these things in. And I'm just trying to provide a way to set this out and keep all your work nice and neat and give you a chance to get this right. 20 plus 12 equals 32 meters per second. So I think that's a really good question, and it's got all the algebraic sort of substitution type steps in here, because we have a bit of algebra here to explain the speed of this object at different time points on a number line here, and so then we can work out all our mathematics down here. All right, thank you.